Question number 15. An FM signal at 10.7 MHz IF intermediate frequency needs to be digitized for demodulation in the digital domain. If the bandwidth of this signal is 200 kHz, the maximum usable sampling frequency is. So finally what he is asking is important. He is asking what is the sampling frequency. So you might have already studied the Nyquist criteria. The Nyquist criteria state that the sampling frequency must be greater than or equal to 2 times the maximum frequency component of the signal. This is valid generally for low pass signals. For band pass signals, the pass for high pass signals you can call, or band pass signals, it is nothing but 2 times FM or 2 times highest frequency component, divided by floor of highest frequency component by FH minus FL. I'll explain you what is this all. Okay, first let me solve this question, then I'll discuss all this in the extension. Fine. So it is given that there is an FM signal, and we'll go back to the question. FM signal is at 10.7 megahertz. So at some station, it is at some station 10.7 megahertz, and it has bandwidth. In the sense, suppose if you have your FM, it has some bandwidth, so it can within this zone this FM is visible. Just like you can hear some FMs like 92.7 FM. Some FMs you can hear only in the cities, so sometimes they are not clear if you go to remote places. So that indicates the bandwidth is limited to certain area. So in a similar way, the bandwidth of certain FM is given, and whose center frequency is like 92.7, like that. The center frequency is 10.7 megahertz is given, and it needs to be digitized for demodulation in the digital domain. If you don't understand this, doesn't matter, but you need to understand the keywords. FM signal which is at 10.7 and it is having bandwidth 200 kilohertz. So overall bandwidth of this is 200 kilohertz. So to the left it can go. Here we are visualizing circular fashion, but in general it will be in a linear way. So 200 to left, 100 to right. So 100 hertz will nothing but 10.6. If it is in mega, it becomes 0.1, 10.1 mega, and it becomes 10.8 mega. So the difference between this is nothing but 0.2 megahertz, which is nothing but 0.2 into 1000 kilohertz. This is nothing but 200 kilohertz, which is according to the question. Now we are on the track. Now let us see. So the lowest cutoff frequency is FL. This is FL, and this is the highest cutoff frequency, just like a filter. So what is a sampling frequency? Whenever there is a pass band, something like this, in this band the FM is popular, or the FM can radiate, beyond which it is very difficult for you to hear the FM. So in this range, so this is clearly a pass band signal. The sampling frequency is given by, I'll give you a formula, try to memorize, 2 times FH divided by floor function of FH divided by FH minus FL. You already know FS, this must be greater than or equal, minimum you should tell. Okay, you already know Fs is greater than 2 times Fm. Similar way, same, the numerator is same, only is you need to memorize this denominator. Please try to memorize. I'll tell you what is floor and all those stuff. Now Fs is nothing but it's greater than 2 times highest frequency is 10.8, 2 into 10.8 will get the answer in megahertz. I'm not writing the units, divided by floor of 10.8 divided by bandwidth is how much? 0.2. It is also in megahertz. Fine. This yields to 21.6 divided by floor of, you can divide these two ones, so 10.8 divided by 0.2, so this is giving us 54. So Fs must be greater than or equal to 21.6. Floor of an integer is always an integer. I'll explain you if it is not an integer. So finally 21.6 divided by 54, this yields to 0.4 megahertz. 0.4 megahertz. 0.4 megahertz is same as 400 kilohertz. Just multiply with 1000. 0.4 into 1000 will give 400. So the right choice is option C. So let us see, which is very important, the extension. So consider the following cases. Sampling frequency can be found for low pass signals and band pass signals. For low pass signals, the signal will be near to the origin, okay, or the signal will be near to a DC component. So for low pass signals, the frequency component will be, my highest frequency component will be FM. So the message signal is indicated as below. So for this message signal, the sampling frequency must be greater than or equal to 2 times the maximum frequency component of the message signal. Sampling frequency must be greater than or equal to 2 times the highest frequency component present in the message signal. Then for band pass signals, the band pass signal will be present at a little higher frequencies, and for these signals it will have lower cutoff frequency, higher cutoff frequency, and a center frequency, and exactly it will have replica as its image. So consider one portion of the band pass signal when you are finding the sampling frequency, so from which you calculate FH and FL. These two are very important. So Fs, sampling frequency, the formula for sampling frequency will be different for band pass signals and low pass signals. So Fs must be greater than or equal to 2 times Fh divided by floor of Fh divided by Fh minus Fl. So if you remember this, everything will be simple in sampling frequency calculations. So I'll explain you what is floor function. Floor function is the one in which you need to discard the values after the decimal. So in the sense, let us see the examples. So first one, floor of any integer number, 500. Any integer, it will give same integer, no change. If any points are there, second one, if any points are there after any numbers are there after decimal, just discard it and write the integer value. Even the number after decimal is a large one, 999. You may tend like writing like 501, but it is wrong. Try to discard the values after the decimal. Even the fourth one says, even if you have large number after decimal, try to discard and write only the integral part. So in this way, first calculate the inner brackets, Fh divided by Fh minus Fl, get its value, then apply the floor function. So in this way, you will calculate sampling frequency for band pass signals. This is quite simple and asked in GATE and many other PSUs. Thank you.